This is a second part. In part 1, I think we discussed around 9 questions from work energy and power chapter. Now, can I go to the question directly? All are okay now? Comments, Srinikesh, Surya. Are you ready? Yeah. So question number 10. Yeah, this is the question. And first thing I need to tell you, this is, look at this, it is 2013 advanced. So it is a JEE advanced question. So no need to worry, not that much hard. Okay, let's check. The result of the test, Aditya, it will be published soon. Okay. A small block of mass 1 kilogram is released from rest at the top of a rough track. The track is a circular arc of radius 40 meters. The block slides along the track without toppling and a frictional force acts on it in the direction opposite to the instantaneous velocity. The work done in overcoming the friction up to the point Q as shown in figure is 150 joule. And it is given that acceleration due to gravity is equal to 10 meter per second square. First question is the speed of the block when it reaches the point Q is. When the block reaches the point Q, what is the speed of the block? That is the first question. And there is one more question in this. The magnitude of the normal reaction that acts on the block at the point Q. At the point Q, what is the magnitude of the normal reaction? So we need to find two answers here. So let's check, let's analyze the question in detail. There is a block of mass 1 kilogram. It is released from rest at the top of a rough track. So in this diagram, you can see that this is the top of the rough track. From that point only, the body is being released. The track is a circular arc of radius. So the length of this arc, it is 40 meter. So it is released from in a track of 40 meter. The block slides along the track without toppling and frictional force acts on it in the direction opposite to the instantaneous velocity. So opposite to the instantaneous velocity means, you know that the body will be moving along this path. So at every instant the direction of velocity will be tangential. So force of friction is acting opposite to that. So that is opposite to the direction of motion. That's the direction of force of friction. Okay. Work done in overcoming the friction up to the point Q as shown in the figure is 150 joule. So 150 joule of work is being done against the friction or overcoming friction when it reaches from this point to the point Q. 150 joule of work is being done. Then what is the velocity? What is the velocity when the body reaches at this point? This is the question. So I think question is clear, yes or no? Please comment. Yeah, of course we can apply the conservation of energy concept, Aditya. Conservation of energy means it is given that initially it is released from rest. Release from rest means at this point its kinetic energy is 0. That means at that point that body is having only what? Potential energy. Potential energy, and you know the formula for the potential energy. Look, this height is R only. So if you are taking this as a base level, initially the body is at a height R from the ground. So at that time that body will possess only which energy? Potential energy. So initial energy is potential energy, and you know the formula for potential energy at a height h, it is mgh, but here the height is equal to R. So what is the initial energy of the body? It is mgr. Is that okay or not? So I am writing here initial energy. Energy initial EI is equal to mgr. This is the initial energy. R value is given as 40 meter, that we can substitute after some time. Now they are asking what is the velocity when it reaches the point Q. Velocity when it reaches the point Q. So let's take the velocity when it reaches the point Q as v. So let us assume the velocity as v. then what is the velocity at that point? So we have to find the value of v. For that, you can use conservation of energy. Remember, when the body reaches here, its velocity is v, means it will have a kinetic energy. You know the formula for kinetic energy, half mv square. So what is the kinetic energy at this point? Means it is equal to what? Half mv square. Is that idea clear? Remember, the initial energy of the body is mgr. It is only potential because the body is released from a height r. When it reaches here, it will have a kinetic energy of half mv square. But at the same time, it is doing some work against water friction. That work is given. 150 joule of work is being done against friction. So if you are applying the law of conservation of energy, remember, when it reaches here, what is the energy? Half mv square. By that time, its potential energy will be decreasing. So that decrease in potential energy, you know that decrease in potential energy will be equal to the increase in kinetic energy. Not only that, some amount of energy is being used to do work against friction. So if you are adding that work against friction, that means it is given as 150 joule. That 150 joule plus this kinetic energy, it will be equal to what? The decrease in potential energy. So I am adding, the final energy will be equal to E final is equal to what we can write? Kinetic energy is half mv square. It is the energy gained by it plus 150 joule of work is being done. It is being done to do work against friction. So this is a gain in energy, we can say half mv square plus the work done. But this will be equal to the loss of potential energy. Loss of potential energy means, remember students, the body is starting from here, it reaches here, means we need to calculate how much energy, potential energy is being lost by the body. Alright, for that we need this height, then only we can find. So how to find that height? Vertical height only we need. So to find the vertical height, see, listen carefully here, we need this height, remember. This is the point where, so I'm just drawing a horizontal line here, or we can draw a line itself. Listen carefully. I'm just taking a line. Yeah, I'm drawing a horizontal line. Alright, so you can see that the new height of the body is this much. This much. So how can we find the loss in potential energy? Initial potential energy, we already wrote it, it's mgr minus this mgh will give you what? The loss of potential energy. That loss in potential energy is equal to the gain in this method. For that we need this distance. So the question is, how do we find this distance? Let me take it as x. This I am taking as x. So this is x, means clearly in this diagram from here to here, this will also be x. So my dear students, you can see that this is a right angle triangle with this angle as 30 degree. Because you know this is 30, means this will also be what? 30. This is x. This is x. And you know this distance is nothing but r. So I think to find x, tell me which trigonometric function we will take. By considering this triangle, I need x. R is given, angle is also given. Yeah, we can take which one? Which trigonometric function to find that? Sine or cos? I need x. So x is the opposite side of 30 degree. So we can take sine. Yes. So let's take sine theta from this. Sine 30 is equal to what we get? Opposite side x by r. So sine 30 is 1 by 2. Is equal to x by r is 40. So x is equal to what? We get 20 meters. X is equal to 20 meter. We got it. So at the point Q, the height, this one is what? 20, and the total height is 40. So 40 minus 20, this height will also be what? 20. Now can you tell me what is the loss in potential energy? Remember students, initial energy is mgr. Remember r is equal to 40. So 40 mg is the initial potential energy. When it reaches at this point, the height is only 20. So new energy will be 20 mg. So tell me what is the loss in energy? All of you, please come, and what will be the loss of potential energy? Initial energy is 40 mg. Final energy is 20 mg. So it will be 20 mg only, right? Yes or no? 20 mg. So I'm writing here loss in potential energy is equal to what? 20 mg. Now it's your turn. They are asking velocity. So as according to the law of conservation of energy, this much loss of potential energy will be, it has to be converted into some other form. Some part you can see from the diagram, it is converted into kinetic energy, and it is given in the question that 150 joule of energy is being used to do the work. So you can equate according to the law of conservation of energy, 20 mg is equal to half mv square plus 150. Now it's your turn. Mass of the body is given as 1 kilogram, g is 10. I need the value of velocity. All of you do it and tell me the answer. If any doubt till this, you can ask me. This is the logic of this question. So we need to find velocity. For that you can substitute m and all. Do it. Yeah, Aditya got it. Oh, the other one was your answer only. I thought you were saying that is about the height of this one, 20. Okay, so I think you made a mistake for the first one. Now it's correct, I think. Others also, please do this and tell me the answer. I need V equation. So, I mean V value. We can write half mv square is equal to 20 mg minus 150. No, here no, Aditya, because it is given that work is being done to oppose the friction, no? So there is no other source of energy. It is from that energy of the body only. It is, the work is, that is taking that amount of joule. Okay. So substitute 20 into masses 1, g is 10, so we get 50. Half mv square is equal to 50, or v square is equal to 100, we get. V is equal to 10 meter per second. 10 meter per second. Yes. Is it clear or not? Please comment. 10 meter per second is the velocity when the body reaches the point Q. Aditya, no. Like in this case, if you're considering, if it's a free fall, then it's fine. If it's a free fall, that means there is no other work or there is no scope of losing energy in any other form, then only it will work. Hope you understand. Yeah, others, it's clear now? So I'll be going to the next question here. What is the second question? All of you check. The magnitude of the normal reaction that acts on the block at the point Q. At the point Q, what is the normal reaction? You know what is normal reaction? It is a reaction which is perpendicular to the normal to the surface. So at Q, what is the normal reaction? So for that, let me erase these things and let's redraw the things. Listen, you know that normal reaction means perpendicular. So what will be the direction of normal reaction at this point? It's a circular track. So for a circle, perpendicular means it will be radial. So along the radius only. So this will be the direction of what? Normal reaction. So I'm just marking it as N. And mass of the body, if you are assuming it as m, you know that its weight will be mg. So we can show the weight like this. The weight of the body is acting vertically downward. It is mg. Okay? Yeah. Now we need a component which is along the direction of normal reaction, then only we can solve this. For that, I'm just extending this line here. This angle is 30, means this will also be what? 30. So opposite to that, this will be 30. So this angle will be 60. If it is 60, you can say that this component will be, tell me, this component will be what? Mg cos 60. mg cos 60 is the component acting in this direction. Is that part clear? Yes or no? This direction, how much part of mg is acting means it is mg cos 60. Now what they're asking, normal reaction. So here there is chance of making mistake, like by looking at the diagram we may think that okay, n is equal to mg cos 60. Is that correct? Can we take n is equal to mg cos theta? You know that on a horizontal surface normally we will take, if m is the mass of the body, mg is acting down, n is like this, means if it is at rest, then we can say n is equal to mg, because there is no upward force or net upward force or net downward force. But here the case is different, my dear students. The body is moving in a circular track. You know that if any object is moving in a circular track, it needs centripetal force, yes or no? Centripetal force. And you know what is the direction of centripetal force? Centripetal force direction is towards the center of the circle. So here we can ask a question, who will provide the necessary centripetal force in this case? By observing the diagram you can see that n is acting in this way, mg cos 60 is acting in opposite. So surely n should dominate, otherwise it cannot move in a circular track. So the necessary centripetal force for this circular motion, you can say it is provided by whom? N minus mg cos 60. So we can write n minus mg cos 60 will provide the necessary centripetal force, and all of you know that the formula for centripetal force is mv square by r. mv square by r. Now we can substitute, we need n only, so n is equal to mv square by r plus mg cos 60. All of you substitute and tell me the answer. If they are equal, Aditya, if n and mg cos 60 are equal, which means that what is the net force? It will be 0. That means there is no net force acting towards the center. If no net force is acting towards the center, means the body cannot move in circular track. Here it has to go in circular track, means it needs a centripetal force. So some net force should be acting towards the center. Okay. It won't go upward if n is greater than mg cos theta, because it is moving in a circular track, no? It is the same logic. If earth is attracting towards the center of the sun, is it going towards it? No, because that force is utilizing for what? The necessary centripetal force for the circular movement. The same thing is happening here. It's moving in a circular track, so some force is required, that is n minus mg cos theta. Hope you understand. Yes, Ronak, I think it's the right answer. Others also please comment. Quick. V value already we got it here 10, so substitute mass is equal to 1, v square is 100, 100 divided by 40, radius is 40 plus 10 into cos 60 is 1 by 2. So 10 by 4, 2.5 plus 5, it's equal to 7.5 Newton is the answer for this question here. Correct answer on 7.5. So option A is the right answer for this question. Once again, please note that this is a JEE advanced question which is asked in 2013. Is it okay or not? Please comment, all of you. Please give me a thumb at least if it's okay for you. Can I go to the next? Yeah. So now question number 11. Question number 11. A particle of mass 2 kilogram, 0.2 kilogram is moving in one dimension under a force that delivers a constant power 0.5 watt to the particle. If the initial speed of the particle is 0, the speed in meter per second after 5 seconds is C. This is also a 2013 advanced question, but I don't think the level of this question is an advanced level. It's actually a very simple question. It is not even JEE mains level also. So just try. It's an easy question, all of you. Yes, yes, you can do it. This is not a tough fun. I'll wait. There is no option here for this answer. So it's an integer type 1, like you have to calculate the answer and you have to write it. Ronak, check the unit. Yeah, I think the magnitude is correct. Can I go to the answer? This is very simple actually. A particle of mass 0 moving in one dimension under the force delivers a constant power. If the initial speed is 0, so u is equal to 0. What is the final velocity? Power is given. Power is equal to 0.5 watt. Time is given 5 seconds. So you know that power is equal to work by time. So work is equal to what? Power into time. Work is equal to, work done is equal to, as per work energy theorem, work done is equal to change in kinetic energy. And here initial kinetic energy is 0. So only final will come. So half mv square is equal to P into T. P is 0.5 into time is 5. Mass is 0.2. So half into 0.2 v square is equal to 0.5 into 5. So if you are multiplying with 10 on both sides, these two will be cancelled. So we get v square is equal to 25. Meter per second. Yeah. Clear or not? There is no complicated idea we are using, just a simple logic. One is power work by time, and work done is equal to the change in kinetic energy. Can I go to the next? Question number 12. An ideal spring with spring constant K is hung from the ceiling and a block of mass M is attached to its lower end. The mass is released with the spring initially unstretched. The maximum extension in the spring is. Try. I'll explain the question. An ideal spring with spring constant K. See, there is a spring. Its spring constant is K. And a mass M is attached. Mass is released from its unstretched position. Then the maximum extension, through how much distance it can go. You can take it as x, then solve it. Okay, Aditya, let me check. Others also comment. Yes, Ronak, take your time. Okay, Aditya will check. Yeah. So I'll go to the answer. This is again a very simple question. When it is in unstretched position, again we can use a conservation of energy concept here. When it is in unstretched position, the energy is 0. If this mass is stretched through a distance x, the spring will also stretch through a distance x. If the spring is stretched through x, you know that the energy stored in that one is what? Half kx square. So half kx square is the energy stored in the spring. By that time, this mass will move down for a distance how much? x. So the loss of that potential energy will be mgx. So mgx energy will be lost by it, because you know the formula for potential energy is mgh. So loss in potential energy is equal to gain in energy of the spring. So this is the logic. Now it's easy. 1x will be cancelled. X is equal to 2mg by k. Yes. Option B is the right answer. Yes, Sahasra, right answer. Yeah. Is there any doubt in it? Anybody? Aditya is asking, but why mg is equal to kx is wrong? Aditya, you use the concept of f is equal to kx, f is equal to minus kx, right? But please note that f is equal to kx, f is not the applied force, it is a restoring force. And normally that restoring force is a function of x. But here we are applying a constant force mg only. That is not changing with x. It's a fixed force. That's not the restoring force. It is just we are applying a force of mg. Hope you understand. This is, if restoring force is that one only, then only we can use this formula. Clear or not? So I'll be going to the next question, question number 13. Look at this. A block of mass 0.18 kilogram is attached to a spring of force constant 2 Newton per meter. The coefficient of friction between the block and the floor is 0.1. Initially the block is at rest and the spring is unstretched. An impulse is given to the block as shown in the figure. The block slides a distance 0.06 meter and comes to rest for the first time. The initial velocity of the block in meter per second is v is equal to n by 10. Then n is. Yes. Can you do it? If you have the confidence, I am ready to wait. Or can I go to the answer? Okay. 2 minutes you can take. Can try. Okay, those who are doing, just carry on. Others, just listen here. Mass is given 0.18, that we can substitute later, is attached to a spring of force constant. K value is given 2 Newton per meter. The coefficient of friction, that's also given, it's 0.1. Initially the block is at rest and the spring is unstretched. An impulse is given. So impulse is given means just a push has been given. Ronak, let me check. A force has been given and the block slides through a distance of 0.06 meter and comes to rest. So what you have to understand here is, if this block is moving in this way through a distance x, which means the spring is compressed through the same distance x. So when the spring is compressed, an energy will be stored in it. From there, where that energy is getting, so the energy of the body only, some part of the energy of the body will be transferred. So here we need the initial velocity of the body, that is v, it's given as v. So if you are considering the velocity as v, its initial energy will be kinetic only, so it is half mv square. This is the initial energy of the body. Okay, now what you have to understand here is it is not a smooth surface, it's a surface with friction. That means when the block is sliding, some of its energy will be used to overcome the friction. That means some work is to be done, then only the body will be moved. So this energy, a part of this energy will be used for doing work against friction, and the rest will be stored as the potential energy of the spring, that is half kx square. This is the idea of this question. Initial kinetic energy is equal to. So I'm just writing that concept here. Half mv square is equal to work done plus half kx square. Now the only problem here is mass is given, k is given, x is given, everything is there. But the problem is we don't know work done. Work done means here who is doing work? Friction only doing the work. So work done by friction. Friction formula is, if you are taking friction as F, displacement is X. So work done will be F into X. But how to calculate friction? Friction is mu into N. Mu N into X you will get. What is N here? It's a horizontal surface. No other forces acting. Only weight of the body is acting down. So normal reaction will be mg only. So look at this result. Work done is equal to mu into mgx. Now you can substitute here. Half mv square is equal to mu into mgx plus half kx square. You can substitute the values. So half into mass of the body is given 0.18 into what? V square. We don't know. V square is equal to RHS mu value 0.1. Mass is again 0.18. G is 10. X is 0. What is X value? 0.06. 0.06 plus half into spring constant is 2, x is again 0.06 but x square, so 0.06 square. Just solve this and tell me the value of V. Calculations are there but not a hard one, can do it. Quickly do this. If any doubt about the theory part you can ask me. If this concept is not clear, ask me, I'll explain. So here we get 0.09 V square (10 into 0.1) will become, so 0.18 into 0.06 plus 0.06 the whole square. V is equal to 0.4 you are getting. That means V square is equal to 0.16, right? Yeah, you can check this. You will get V square value as 0.16. After solving this, you will get V square is equal to 0.16. Yeah, correct. So V is equal to 0.4. But remember, the question is not to find V value. The question is, if V is equal to n by 10, then what is n? That's a question. So we can substitute this V as n by 10. So n by 10 is equal to 0.4. So n is equal to 4. That is the answer. N is equal to 4. Okay. So you don't need to worry about the calculation part, that you have the skill. Idea is important. So if this idea is clear, you can do it. So is it okay or not? Half mv square minus mu n. Aditya, mu n into x you have to take, no? How can you subtract? Mu n is only force. Mu n is only what? Force. So we need to subtract work only from that energy. So mu n into x should come. Displacement. See, mu n is frictional force. Frictional force into displacement you have to take, no? Clear? Yes. So I think it's clear. Can I go to the next, all of you? Please comment. Can I go to the next question or not? Yeah. Question number 14. A 0.5 kilogram block slides from the point A on a horizontal track with an initial speed of 3 meters per second towards a weightless horizontal spring of length 1 meter and force constant 2 Newton per meter. The part AB of the track is frictionless and the part BC has the coefficients of static and kinetic friction as 0.22 and 0.2 respectively. If the distance AB and BD are 2 meter and 2.14 meter respectively, find the total distance through which the block moves before it comes to rest completely. A bit challenging question. I'll give you the idea, after that you can try. So please read and try to understand what they are asking. Find the total distance through which the block moves before it comes to rest completely. Complete rest, my dear students. It is why we are specifying the complete rest means, you know that this is a spring. So normally when the spring, this block is going and hitting that spring, means the spring will be compressed and suddenly it will release its energy. So it will push the body back. Isn't it? So they are, in this question they are saying that it comes to rest completely. When it comes to rest completely, what is the total distance covered by the body? You can see from the diagram, the body is starting from the point A. Hey, it reaches the point B first, and remember this path is frictionless. It is given in the question. The part AB of the track is frictionless and the part BC from B to C, BC, not B to D, B to C has a coefficient of static friction. Static friction is 0.22 and kinetic friction is 0.2. If the distance is AB and CD, so AB is given as 2 meter and BD is given as 2.14 meter. These two distances are given. Find the total distance. So total distance means what we need to find is only the compression. If the spring is compressed through a distance x, what will be the total distance? The sum of all these 2 plus 2.14 plus that compressed distance, that will be the total distance covered. So the only thing you have to calculate in this question is that x value, which means the compression of the spring. That idea is clear or not? But the question is how? How can we find that compressed distance? So you can understand here, this body is, initial speed of the body is given as 3 meter per second. So velocity is 3 meter per second. Surely, since there is no friction from the path, for the path A to B, there is no opposing force, there is no acceleration or deceleration. That means when the body reaches at the point B also, its velocity remain as 3 meter per second. 3 meter per second. Now you should be very careful. Here onwards, there is friction. There is friction. So the final energy of the spring, again you can use the previous question concept, same idea. The energy of the spring, half kx square, plus the work done against the friction will be equal to the initial kinetic energy. So the same idea only I am using here. Initial kinetic energy equation, we can write half mv square will be equal to work done plus half kx square. Same formula for the previous question, where x is the compression. But here the confusing part is, what is W? W is work done against friction. So again you can use the same idea, work done against friction. Look, W is equal to F into displacement. But my dear students, one of the mistake, there is the probable chance of making mistake is, what is the displacement? When we are taking frictional force into consideration, which distance you have to take? Can anybody tell me? What is the frictional, the distance when we are considering the frictional force? How much distance we need to take? No, Aditya, that is what I am saying. See, it is given that B to C, there is friction. So when the spring is compressed through a distance x, so through that distance also friction will be there. So when we are calculating the work done against friction, the displacement that you should take is from here till here. So it will be 2.14 plus x. Idea is clear or not? Because the spring is compressed through a distance x. So when we are calculating frictional force, you have to write F into 2.14 plus x. Now F is what? Mu n. Mu n is mu mg into 2.14 plus x. So that value you can substitute here. So look, what is the result we are getting? Half mv square is equal to, W is mu mg into 2.14 plus x plus half kx square. So in this equation you can see there is only one unknown quantity, that is x. Solve this and find the value of x. Take your time. Concept is, if the concept is not clear, ask me, I'll explain again. Aditya, are you okay how we are getting the distance as 2.14 plus x? Yes. So mass is 0.5, so half into 0.5 into v square. V is 3. 3 square is 9. Okay, one question to you. Here there is mu, right? Which value of mu we have to take? Because you know there are two mu values are given. One is coefficient of static friction. Coefficient of static friction is 0.22 and coefficient of kinetic friction is 0.2. So which mu we have to take? Is it 0.22 or 0.2? Please comment. Static or kinetic? Ronak is saying it is kinetic. Yes, surely it is kinetic because the body is in motion. The body is moving. So it is kinetic. Kinetic is 0.2, so we can substitute 0.2. Mass is again 0.5. G is 10 into 2.14 plus x plus half into k is 2 into x square. This will be 9 by 4. This will become 1. 10 0.2 into 0.5 is 1 into, so it is 2.14 plus x square. So it is looking like a quadratic equation in x. Anyway, you can solve it. Nine point four is 2.25. Sorry, 9 by 4 is 2.25 is equal to 2.14 plus x square. So we get x square plus x, 2.25 minus 2.1 minus 0.11 is equal to 0. What is x value? Aditya, what is x value you got? Yeah, x will be 0.1, correct. Yeah, solving this we get x is equal to 0.1. So the total displacement will be 2 plus 2.14 plus x. Yeah, 4.24 will be the answer. Bit lengthy calculation, lengthy concept. Yes, but any doubt you have? Anybody? Concept is same as the previous question. We are equating initial kinetic energy of the body, which is equal to work done against friction plus the energy of the spring. But the only additional thing you have to notice, the displacement by friction, because the spring is compressed means you have to take that distance also into consideration. Yes, now, no doubt, why did they give us the coefficient of static friction? See, it comes to rest completely, it is given. So, we need to check, like, after one compression, do you think that the body will come to rest suddenly? So that I can tell you how to find. See, what is the distance to which it is covered? 0.1. Then how much restoring force will be there in the spring? Restoring force I am just calculating. You know the formula of restoring force, it is Kx. K is given as 2 into displacement is 0.1. So you can see it is 0.2 Newton. This is the restoring force in the spring. Yes or no? Yeah. Now let me simply calculate the static friction. Static friction value F is equal to mu n. So mu is given as 0.22. 0.22 into mg. Mass is how much? 0.5 into g is 10. Okay. So we get this one as 5 into 2.2 into 1 by 2. So 1.1 Newton. Correct. This is what? The static limiting friction. Limiting friction value is this much. That means to move the body, once the body comes to rest, to move the body, a force which is greater than this one should be required. But here what is the restoring force, it is only 0.2 Newton, which means the body will not move. That means even after the first compression itself, the body will come to rest. For that purpose only, that coefficient of static friction value is been given. It is to check whether the body will move after the first compression. Answer is no, because you can see the limiting friction is 1.1 Newton. Here the force acting is only 0.2 Newton. Is that idea clear? All of you? Please comment. Can I go to the next? You have to practice these kind of question, you know. Once you get an idea, see these type of question, whatever question they're asking you, you will understand, okay, here the concept that we are using is energy conservation, like initial kinetic energy is equal to work done against friction plus the final energy. Yeah. Yes. Srinigesh, once completed, tell me. Yeah. So I'll be going to the next question number 15. A uniform cable of mass m and length L is placed on a horizontal surface such that 1/nth part is hanging below the edge of the surface. To lift the hanging part of the cable up to the surface, the work done should be. This one, do you remember the question which we discussed in the last class? Prithvi, you need time for the previous question? Okay, fine. Look, hope you remember this same concept of question we discussed in the last class, but in that case, it was 1/3 of the mass of the chain, but here it is 1/nth. So can you try? So this is the situation. There is a block and a chain is hanging on it. 1/nth part of it's hanging below the surface. So work done to lift it. Try. MGL by, okay, Aditya, let me check. So first we have to find the mass of the hanging part. This much part is hanging. So surely total mass is M, means it will be m/n only. So mass m is equal to what? m/n. Okay, what about the length of this one? It will be L/n. From here to here, the distance will be L/n. But when you are calculating the work done to lift, we need the height. Hope you remember what I told you in the last class. This is not a point mass, so we need to assume that the mass is concentrated at its center of mass. So center of mass means at the midpoint. So height means only half of that. That means half of L/n is L/2n. So h is equal to what? L/2n. Yes. Now we can use the concept of work done to lift a body. It is mgh. So m is m/n, g is g itself, h is what? L/2n. L is capital L, so L/2n. So the result is mgL/2n square. mgL/2n square. Yes, Ronak, correct answer. Easy now. So you can see that these type of questions are repeating. Work done to lift a chain. Can I go to the next? If any doubt anybody have, please ask. No, right? Going to the next, question number 16. Yeah. Look at this. A smooth wire of length 2 pi r is bent into a circle and kept in a vertical plane. A bead can slide smoothly on the wire. when the circle is rotating with angular speed about the vertical diameter AB as shown in figure, the bead is at rest with respect to the circular ring at position P as shown, then the value of omega square is equal to. Again, you can see this is 2019 main question. So look, first understand the question. There is a vertical circle made by a metal, a wire, smooth wire. It is in a vertical circle. Remember, it is like this. Okay. And what is its radius? Its radius is given as, actually its circumference is given. Length is 2 pi r means circumference is 2 pi r. Circumference is 2 pi r means radius is r. So that is an indirect information. Radius is r, but it is there in the diagram. So no need to worry about that. Then that vertical circle, so circle is kept like this, that vertical circle is rotating with an angular velocity omega. As shown in the figure. The bead is at rest with respect to the circular ring at position P. So in this diagram, you can see this is the point P. So at that point, that bead comes to rest. Then what is the value of omega square? That is the question. Okay, so for your understanding, let me draw a bigger diagram. Look at this. So let it be the circle, and through the middle there is a line. Yeah, it is at the midpoint, so I'm just marking this as the center of the circle. And there is one more horizontal circle is shown in the diagram. You can see that. So there is a horizontal circle. Yeah. And here only the point P is being marked. P is here. And when the bead reaches at that point, it is given that it is at rest. It is at rest. Okay. So diagram is okay now? First question is, it is coming to rest with respect to, it means if you are releasing a bead from here, the first question is, if you are releasing a bead from here, it is coming down. We are not applying any force on that bead, but still it is coming down. Can you tell me which force is acting on it? It is coming down means, what is the force acting on it? Which force is pulling the bead down? All of you, please comment. We are not applying any force on it. It is coming down due to what? That's the base of this question. Please comment, anybody? Downward motion is because of its weight only. So the weight is acting down. But see, it reaches at this point, then it is not coming down. So what happened to that weight? That's a big question. Weight is there, but what happened to that? So I'm just marking the weight like this. You know, if m is the mass, the weight will be what? Mg. Weight is mg. Okay. And at this point, there will be normal reaction also. So since it is a circular path, what will be the direction of normal reaction? Normal reaction will be radial. So I can show the direction of normal reaction along this line. And in that line, I will be showing a vector. Look at this. This vector is actually the normal reaction. Okay, this is a normal reaction. We can represent it by the letter N. That's clear now? Yeah. Now, I am going to resolve this N into two components. I will tell you the purpose. One component I can show like this, and the other component will be like this. So, from this diagram itself, you will get an answer. Why it is not moving down means the weight of the body it's not a disc that this ring itself, it is like a, it's like a loop. That loop is rotating. So surely this circle is showing the path through which that bead is rotating. Clear, Aditya? What is happening there? Yeah. So here I'm marking this angle as theta. This angle, if I'm marking as theta, then this angle will also be theta. Surely this will be n cos theta, and this is what? N sin theta. So what we can say from here is, why the bead is not moving down further means its weight, that is mg, it is balanced by n cos theta. So I'm writing that formula here. Mg is equal to what? N cos theta. Mg is equal to n cos theta. Is that step clear? Yes. Now, one more. Then the question is, then what is the role of n sin theta? N sin theta is acting in this direction. That bead is moving in circular path. It needs centripetal force. So who will provide that centripetal force? N sin theta. So n sin theta is providing the centripetal force. But remember students, radius of that track, check this diagram, it's given as r by 2. So when we are writing centripetal force formula, what we can write is m into v square means, okay, v square by r is what? R by 2. It is provided by whom? N sin theta. N sin theta. So I'm taking this as equation number 1 and this as equation number 2. Remember, we need to find omega square value. But in this equation, there is no omega square, but there is v square. You know how to convert. So before that, before going into it, just divide this to simplify. But before that, this 2 will go up. We get 2mv square. Equation 2 by equation 1. That's what I'm doing. So we get 2mv square by r by mg is equal to n sin theta by n cos theta, that is equal to tan theta. Tan theta. Is that step clear? Tan theta. Now m got cancelled. We get 2 into v square by rg is equal to tan theta. Tan theta. V square is equal to rg tan theta divided by 2. Rg tan theta by 2. Is that okay? Now we need r omega value, omega square value. So v square is equal to, v is equal to r omega. So squaring, we get r square omega square is equal to what? Rg tan theta by 2. So now 1 r will be cancelled. So we get omega square is equal to what? G tan theta by 2r. Omega square is equal to G tan theta divided by 2r. But if you are looking at the option, you can't see such an option. We need omega square only. No need to find its square root. Omega square is equal to G tan theta by 2r. Now, is there a way to find tan theta from the diagram? Then that's it. We can find it easily. Tan theta value. That only we have to, that also we have to find from the diagram. How do we find tan theta? From this given diagram. See, this distance is r by 2, no? And this is what? R. So to find tan theta, if you are taking this triangle, tan is opposite side by adjacent side, r by 2 by, we need this one. For that you can use Pythagoras theorem first. Sorry, this one is small letter r only. So I need this one to find tan theta. How can we find that one? It will be root of r square minus r by 2 the whole square, that is r square by 4. So 4r square minus r square by 4. So root 3 r by 2. This will be the value of this one. Root 3r by 2. Then what is tan theta from this triangle? Tan theta is equal to opposite side, that is r by 2. So I am writing here tan theta is equal to opposite side is r by 2 by adjacent side is root 3 r by 2. So it is equal to 1 by root 3. Tan theta value is 1 by root 3. Okay. So substitute here. So we get omega square is equal to G by 2r into what? 1 by root 3. Is it there? G by is there anything missing? Two G by R root 3 is there. Check if there is any mistake. So M got cancelled. 2 into V square by RG is equal to tan theta. V square is equal to RG tan theta by 2. G by, check if there is, one second, V square, what did you, yeah, V square is equal to R omega, it's correct only, no? Aditya? Yes, V is equal to R omega, it has to be R by 2, yes, that's a mistake. Here V square, so V is equal to R omega means over there it has to be R by 2. So we get R square by 4 here, right? Yeah, that's a mistake we made. R square by 4. So that 4 will come here. So 4 by 2 means there will be a 2 in the numerator. Fine, that is a mistake. That R will be here and a 4 will be here, right? Okay. So what we get here is 4 G by R. No, 4 by 2 will be 2 only, right? Sorry. There is a 2 here. So we get 2G by R into tan theta. Now we can substitute 2G by R into what is tan theta we got? 1 by root 3. 2G by R root 3, correct. 2G by R root 3. This is the answer. Yes. Yes, obviously bit confusing question. If doubt is there, you can ask me, I'll explain again. So the idea we use here is, here it is coming to rest means the weight should be balanced by something. And since it is moving in circular path, we can say the part of the weight will be utilized for something else. So some part of the weight is utilized for what? The normal reaction, and rest is utilized for providing the centripetal force. That concept only we use here to get it. Clear or not? Copy this. If doubt is there, ask me. So the answer is 2G by R root 3. This is again, you can say it's a main question, not an advanced one, but look like an advanced type. Yeah. See, Aditya, what the concept of the question is like, it is come to rest at a particular point. At that point, that means how, with what velocity, if you are rotating that ring, you can bring that bead to rest. So from here, what you understood is, if you are rotating with this much of angular velocity, it will come to rest. Now the concept is, at that velocity, what is happening? At that velocity, it needs some centripetal force. So that centripetal force is provided by the weight of the bead. So the weight of the bead is being completely utilized for providing the centripetal force and for the normal reaction. That concept only we are using here. Okay. And it can happen at any other point. So this point is just like a rough point only. It can be at any other point. Got it? Okay, so I think the time is up. So today we have discussed some bit advanced level questions. So see you with some more important questions in the next class. Thank you very much. Take care.